Okay, so I think we did till question 4 last class, the regular non-gun.
Yes.
Okay, so we'll have to start from, I want to park question 5 for the end of the class. It's a little involved one. I don't want to rush through that. Let's finish 6 through the rest of the paper, and then we'll come back to question 5. Okay, all right. So this one, Ashi, what did you get on this one?
1 second. The sixth one.
Sixth one, yes.
So 2019.
2019. Okay. Am I sharing screen, guys? You're able to see my screen or not
No,
yet? No, because I'm not even sharing. That's why. Okay. All right. Yes. So 2019. Rachit, same answer.
Yes,
Yeah.
sir.
So Ashi, how did you do this, please?
yes. So it says you choose a 3 from the 6th prime. So first it says the mean of 3 primes is 2023. So I multiplied it by 3 to get the sum of all 3 of its primes.
Mhm.
You get 6069. Then
Okay.
I added all the 6 primes.
Mhm.
I got 12126. 12,126.
Okay.
Then I subtracted 6069 from 12126.
Mhm.
I got 6057.
Mhm.
Now 6057 is the sum of all 3. So the mean will be 6057 divided by 3, which is 201.
Okay. Sounds good. Rachit, anyway, can you make it a little bit more efficient?
So what?
Can you make it a bit more efficient? Or did you do pretty much the same thing?
Yes, sir.
Okay. I can clearly see one way in which you can make it slightly efficient. Arnav, yes.
No, so I just did like trial and error. I just added up all that made sense because I didn't really do this way. I didn't really get how to do this way. I just
But
did trial and error.
yeah.
And
Yeah,
added up
trial and error. If you get lucky, then you can go do it quickly. If you don't get lucky, then it can drag you for a long time.
so
But
I got very lucky.
okay, yeah, what she did was good, but you can make it slightly more efficient. Anyone?
So you can
Yeah.
just remove all the 2000s.
Exactly. We can deal with small numbers. We can just deal with 3, 11, 17, 27, blah, 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 and exactly do the same thing. Finally, you'll get an answer 19. Add back the 2000. In this case, he was kind enough to put 2000 exactly. But just remember the same question had been 2603, 2611, 2617. The 2600 can be annoying and you have to keep track of everything. More scope for doing mistakes. Remove the commonality up front and then add it back at the end. That's the main thing I wanted to highlight. Make sense, Ashi? How we can get a little bit more efficient? Okay, cool. Let me just ask one other question on this. Okay, so there are 6 primes here, right? Okay, 6 primes here. How many factors will be there for the product of these 6 primes? So you take all of these 6 primes, you multiply. Product of these 6 primes. Okay, that resulting big, humongous number will have how many factors? That's the question. Okay, all of you think about it for a minute or so.
So factors or prime factors?
Factors. So for example, 6 has 4 factors, 1, 2, 3, and 6.
So 7 factors, right?
Why 7 factors? The product of these 6 numbers.
So there are 6 primes. So
Mhm.
the only factors that they have is 1 and itself.
Yeah. So for example, had the numbers been small numbers, 2, 3, 5, 7, 11, and 13. If you look at the product of these 6 small prime numbers, you're saying they'll have only 7 factors. Let's deal with a simple number like 2 into 3 into 5. Forget even 7 into 11 into 13. 2 into 3 into 5 is 30. 30 has how many factors? Clearly more than 7, right? We can start listing out. So I've already exceeded 7 right here. In fact, it has 8 factors. Even the product of 3 prime numbers. Do you agree?
Yeah, no, I just thought of something else.
Okay. Do you recall, Jan, do you recall if a prime number is the product of 2 power a times 3 power b times 5 power c, how many factors will it have in terms of a, b, and c? Or rather, let me put in some numbers, right? We did this in the last class.
Yes,
Or-
it'll be a plus 1, b plus 1, c plus 1. Like
Exactly. So it's
that.
2 power 5 into 3 power 10 into, let's say, 5 power 7. It will have 6 into 11 into 8 factors. You all agree? You remember this from last class? Now, can you
Yes.
do this problem? Now, what will the answer for this problem be, therefore, the one I asked?
So,
Yes.
can you repeat the question once again?
I take all of these 6 prime numbers, 2003, 2011, and so on. I multiply all of them. That humongous big number will have how many factors? If you're able to answer this question, then it's just an extension of that, right? Akshaj, what do you think?
I'm not really sure.
Okay, you understood why 2 power 5 into 3 power 10 into 5 power 7 has so many factors. That you understand, Akshaj?
Yeah.
Okay, so very similar, right? So had it been 2 power 1 into 3 power 1 into 5 power 1, right? That had 2 into 2 into 2 factors, right? Therefore, 8 factors. Those are the 8 factors that we listed here. Had we continued along with 7 power 1 into 11 power 1 into 13 power 1, they'll have a further 2 into 2 into 2, therefore 64 factors. And doesn't really matter whether the prime number is small or big. Instead of 2, if it's 2003, it's still a prime number. So whether it's 2003 or 2007, does not really matter, or 2011 in this case.
13 factors, right?
64 factors.
Yeah.
Why? Because it's like
Oh, right,
six.
right. Yeah. Sorry.
There are 6 prime numbers. Let's say P, Q, R, S, T, U. All of them raised to the power of 1. That's it, right? So 1 plus 1 into 1 plus 1 into 1 plus 1, 6 times. So therefore 64 factors.
Yeah, sorry, I just accidentally added them. I meant to multiply.
Okay, but understood, guys? Fairly straightforward, right? I would have expected you guys should pounce on it. I was gracious to give 1 minute. You should have stopped me and said, I don't need 1 minute. I need 15 seconds or 5 seconds, actually. But does it make sense? Factors. Sana, you're clear? Neve, does it make sense? Okay. All right. So let me just ask one more question then. So if I take all of these prime numbers, okay, let's say these are P, Q, R, S, T, U. Okay, these are the 6 prime numbers corresponding. So this is P, this is Q, and so on. This is U. Okay. So if I have a number which is one second, let me just think. Okay, if I take any 2 of these prime numbers, square them and multiply. For example, I can randomly take any 2. I can take R and T, for example. I multiply and then square them. How many factors will that number have? I take any 2 of these 6 primes, multiply them, and square that result. How many factors will that resulting number have? Sana, can you take this?
If you square the number, then it has 2 times the amount of factors.
Is it?
No, not 2 times, but like, is it multiplied by 2 as?
Okay, Rachit.
So I don't understand the question.
I take of the 6 prime numbers, I take 2 of them. I multiply, I square. Okay, that resulting number will have how many factors? I'm in a class.
17.
So how 17? I'm not saying 17 is right or wrong, but how?
So you can just take P, but
Okay.
and let's just take P and Q for
T
example.
and Q. T and Q, you're taking T and Q and squaring it. Yeah.
Yeah, okay. So basically T will have 1 plus 1 and Q will have also 1 plus 1, which will make it 2. So 2 into 2 equals to 4. 4 square 16. 16 plus that, and every every number is divisible by 1. So 4 square plus 1, which is basically 16 plus 1, 17.
Way off. So you guys are not understanding how to do this plus one wala business. So you will take the prime factorization. The prime factorization is T square into Q square. Now the T is a prime number, Q is a prime number. Now you add 1 to each of these powers and multiply. Therefore, 9 factors. As simple as that. Yeah. Sorry, someone was asking a question. I heard some hello. Yeah. Does it make sense, Arnav?
Why is
I-
that plus 1?
Okay. Can someone explain why that plus 1 is? I did explain this in the last class. Arnav, yeah. Can you explain why the plus 1?
So every number is like, so let's take a prime number in this case. It's always divisible by itself and the number 1. So supposing 2023.
Okay, but when it's squared, it also gets divisible by then another one.
Okay. All right. I'll explain this concept again. Looks like a lot of you are a little vague on this. Okay. Forget this problem. Let's take a simple problem, right? So let's take a number which is 2 power 3 times 3 power 1 times 5 power 2. A number like this. What is this number? 8 into 3. Well, I don't care what this number is, but anyway, 8 into 3, 24, 24 into 25, which is 600. Suppose the question is, how many factors does 600 have? One way would be to list out all the factors pairwise, 2 into 600, 2 into 300, 3 into 200, and so on. By the time you finish, the bell will ring. It's not something you want. If you're not interested in what the factors are, if you're only interested in the count of the factors, how many factors, you're not interested in listing down all the factors, then this is a very laborious process, right? Long process. Okay, so don't do that. No one is going to ask you to list the factors. Very often the question will be how many factors. So how to approach with how many factors? So listen to this carefully, guys, once and for all, please. This is very extremely important. I've done this at least 2 times. Now, this is a basket of 2s. 2, 2, and 2. I have 3 2s. I have a basket of 3. In fact, there's only 1 3. I have a basket of 5s. 5 and 5. Now, how do I generate a factor of this number 600? I go to each bag. I grab a few of them. For example, I can go to the 2 bag. I can grab 1 2. I can go to the 3 bag and grab 0 3s. And I can go to the 5 bag. I can grab both the 2 5s. So I can go to each bag and grab as few as 0 and as many as the total number of that numbers, how total number of objects that you have in that box, right? Does it make sense, Sana, so far? Okay, so if I do this product, I get a unique factor. So in this case, the number is 2 into 1 into 25. The number is 50. 50 is a factor. Like that, Arnav, you don't have to count 0 separately. Sorry, 1 separately. If I go to the 2 bag and take 0 of them, 0 from the 3 bag and 0 from the 5 bag, that is also one factor, namely the number 1. If I go and take all the 3 2s, all the 1 3s, all the 2 5s, then also I get a number which is a factor, which is itself. These are the 2 extreme cases. But those are also getting counted in the normal process. You don't have to count or account for them separately, right? So to summarize, what do I have? If I go to the 2 box, I have 4 options. I can either choose 0 2s, 1 2, 2 2, or 3 2s, right? And therefore, it's 2 power 3 is, we had 2 power 3, right? Therefore, we increase the index by 1. So there are 4 options as far as the 2s are concerned. Does it make sense, Sana? Ashi, as well? You're with me? Okay. And if I go to the 3 bag, there's only 1 3. Therefore, I have 2 options. Either I can pick 0 3s or 1 3. Therefore, 2 options. If I go to the 5 box, I have 3 options, 0 5, 1 5, or 2 5. Therefore, there are 3 options. And each option I can mix and match. It's like wearing a shirt and a tie and a pant, right? I can mix and match and make some dress, right? So each of these 4 into 2 into 3 is a unique factor, including one of them being 1, including one of them being 600, including one of them being a number like 50, and all of them. All of them get accounted in this 4 into 2 into 3, which is 24 factors. Does it make sense, guys? Okay, Gyan, are you with me? Neve? Okay, I want you guys,
Yes.
any question on factors, you guys should be able to ace it from now onwards. Now, coming back to this question, what did I ask? I asked, initially I said the product of these 6 numbers, which is just, I don't care how big the numbers are, as long as they're prime. 2003 is as good a prime as the number 2 is. The magnitude of 2003 doesn't mean anything. 2003 is prime means it has only 2 factors, 1 and 2003. That's it, right? So I have, for example, I have a box of 2003s, namely there's only one 2003. 1 2011, 1 2017, and so on, right? I go to each box, I have 2 options, either to pick that prime number or not pick that prime number. Hence 2 options, 2 options, 2 options, 2 options, 2 options, 2 options. Therefore, we said there are 64 factors, right? That was the first question I asked. Then I asked, I pick any 2 numbers and multiply them and square them. So effectively, I
Is
get,
this for, sorry to interrupt, but is this for only prime numbers?
yes, only when you break it down to prime factors, we
Okay.
can do this process. Otherwise,
Yeah.
because they don't clash with each other. The only way to generate anything in the 3 family is just using 3s.
Okay,
Like
so for example, if a question asks 3,503, okay, no, I think that might be a prime number. 3,501.
Okay.
And you have to find all the factors.
Okay, let's do this. So 3,501 is divisible by 3. 3 plus 5 plus 1 is 9, right? So let's divide by 3. So what do we get? 3 times 3 ones are 3, 3 ones are 3, 3 6 are 18, 1167. Correct? 114, 50. Yeah, correct. And then, in fact, it's
That's
divisible
also
by 9.
divisible by 3.
Sorry.
That's also divisible.
Yeah, exactly. In fact, when I added this, it was divisible by 9. I should have realized it then itself. So anyway, so 3 3s are 9, 26 3s are 24, 9. All right, 389. Correct.
Yeah.
Now, further, let's see whether we can break down 389. So 389, to test whether 389 is prime or not, we have to test all the prime numbers till approximately the square root of 389. Agreed, Sana?
Yeah.
We have gone through this, right? Neve, you understand this? To test if it's prime, we only need to go approximately till square root of 389. Neve, what is approximately square root of 389? Very approximately.
18.
Yeah, 18, 20. 20 is close, right? 400 is very close to 389. So I only have to check whether it's divisible by 2, 3, 5, 7, 11, 13, 17, and 19. That's it. If I test these, I'm done. 2, clearly it's not. 3 plus 8 plus 9 is not divisible by 3, therefore not divisible by 3, not divisible by 5. Is it divisible by 7? Let's check. Just 1 second.
Sir, it isn't.
Yeah, it's not divisible by 7. 11 के लिए क्या check होता है? Alternating numbers we have to add. 9 plus 3 is 12. 12 minus 8 is 4, which is not divisible by 11, and therefore not divisible by 11. 13 ka? 13 2s are 26, 129, no. 17, I'm just doing it quickly. The answer is no. 19 also no. Therefore, 389 is prime, which means this number is 3 square into 389. Now, Sana, you tell me how many factors does this one have? Fatafat.
So it would be 3 times 1.
3 times 2, because
Sorry,
it's
3
389
times
per
1
1.
and 389. So 6.
Exactly. So this number has 6 factors. In fact, we can list down all of the 6 factors very quickly, right? 1 into 3501, that's one factor. 3 into 1167, okay? And then
And
9
3
into 389.
Yeah, 9.
These are the 3 6. But you don't have to list. I'm just saying. In this case, since 6 was a small number, I thought I'll list it. Does this make sense, guys? Okay, all of you clear? Ashi, you're with me? Snigdha, I don't see you. Why? Did you recently join or were you there from the beginning?
So my camera is not working.
Oh, okay. No, but did you join the class late? I don't remember seeing you in the beginning of the class.
So I joined at 3:40.
Okay. All right. Can I have your mom send me a message saying the camera is not working? I mean,
Yes.
not that I don't trust you, but I want to make a general principle, right? Anyone camera is off, I need to hear from the parent.
Yes, sir.
Okay. All right. Cool. Let's move on to next question. Yes.
3 square because there are 2, 3.
Saurabh, I didn't understand. Connection is very poor. What is it?
So the 3 square that you've taken, 3 square into 389.
Yeah. Yes, Saurabh, go ahead. 3 square into 389.
3 square because we got 3 twice in the prime factorization.
Correct.
Okay.
Sorry, I'm not following your question. Yes, 3 square into 389.
I got it.
You got it, no? Pakka, no? So it's
Yes.
3 square, and so it's a bag of. So you have a bag of 3s. 3 is a prime number. There are 2 of them. You have a bag of 389. There's only 1 of them. Same process. You go to the 3 bag. You can either pick 0, 1, or 2 3s. You go to the 389 bag. You can either pick 0 or 1. Therefore, 3 into 2, 6 possibilities.
Yes.
Of mixing and matching and connecting, making a factor. Okay. All right. Next question. What is the remainder? Okay, Neve, did you do this one? What is the remainder when 2, 3, 2, 3, 2, 3, blah, blah, blah is divisible by, divided by 32?
No, sir.
Okay, how far did you get along with this?
So not really. Like I kind of understood the question, but I didn't know where to start.
Okay, all right. Let me help you. What is the test of divisibility by 4?
The last two numbers should be divisible.
What is the test of divisibility by 8?
The last three numbers should be divisible by.
Okay, now why is it that for divisibility by 4, we check the last 2 digits should be divisible by 4? Does anyone know? Rachit, do you know? To test if something is divisible by 4, why is it sufficient to test last 2 digits?
100 is divisible by 4. Therefore, anything in the hundreds place will be divisible.
Exactly. Neve, did you understand that? For example, if I have 78,968, right? Now he's saying 100 is divisible by 4. So why does that matter, Neve? Can you connect from here?
So then maybe the last two digits like could be divisible by 4. Like
Yeah.
anything in like the hundreds place.
Yeah. So 78900 is perfectly divisible by 4. Because 100 is divisible by 4, I don't really care what is there before it. So I can start counting from here. And then if I'm able to reach a multiple of 4, then I'm good. Which is why I only focus on the last 2 digits. Because the previous 100 would have been divisible by 4. Does it make sense, Neve? Okay. And similarly, Neve, why do you think divisibility by 8 के लिए last 3 digits देखते हैं हम लोग? Why do you think that's the case?
Maybe because I think 1000 is divisible by.
Exactly. 1000 is divisible by 8. 120, I don't know, you don't have to raise your hand. 125 times 8 is 1000. Therefore, the last 3 digits, if I ask a number, 76,000 or whatever, some big number, 761,384 something. I know 761,000 is perfectly divisible by 8. So I don't really care what is there before this. I only need to start counting from 000 onwards. As long as this number is divisible by 8, the number is divisible by 8. Okay. And why is that? Because 100 may, there are, in fact, divisibility by 2 ke liye, what do? We look at the last digit and see if it's divisible by 2. That's what we call as even number. But essentially, same thing you're doing as 4 and 8. 4 ke liye 2 digits, 8 ke liye 3 digits, 2 ke liye only 1 digit, because 10 has only 1 2s in it. 100 has 2 2s. 1000 has 3 2s, which is why it's a good test of divisibility by 8. Right? And similarly, therefore, by extension, Arnav, can you complete it? What do you have to do for divisibility by 32?
Okay, so I did it in a very different way.
Okay.
But so 2 square into.
Okay, we'll discuss your way after that. But based on our discussion so far.
So I joined from a different device. Am I visible?
Yeah, you're visible now. Yes. Okay, good. Thanks. Arnav, so yes, we'll discuss your method also, Arnav. But based on my discussion so far, what do we how many digits should we take?
5 into 5 raised to 5. So basically 2 raised to 5 into 5 raised to 5 is
you don't care what the number is.
Last 5 digits must be divisible.
Exactly. Last 5 digits is what we have to check. So 2 3, and then 3. That's it. There's no, we don't. So as long as we check when this number is divided by 32, so I don't really care about all of these big numbers ending till here. I don't care, right? I only focus on the last 5. Does it make sense to everyone? Last 5. So now the last 5 is 32,000 plus 320 plus 3. And therefore, this is perfectly divisible. This is perfectly divisible. Therefore, the remainder is very simply 3. Does it make sense? Okay, so I was hoping this is how some of you might have done it. But Arnav, can we hear what you did, even though it was long? Let's understand. What was that? Just 1 second. My alarm. Just 1 second. My alarm is ringing.
Yes, sir, sure.
Yeah, go ahead. Go ahead, Arnav.
So what I chose to do was I chose to remove the first 2. So I made it 2 into 10 raised to 45. So there's 46 that
46 digits. Okay,
Yeah.
all right.
so 2 into 10 raised to 45 plus 323232. I kept continuing that.
Yeah.
And then I did plus 3. So I removed that last digit of 3 also. So I know that 2 into 10 raised to 45 is divisible because 2 into 10 raised to 5. So,
Okay.
and then 3232 I know is also divisible. And because they're 40 digits or something, no, they're, wait. Yeah, that's also divisible. I don't remember exactly how I figured that out.
Okay.
So then the only digit that's left is our plus 3. Therefore, saying that plus 3 is the only and plus 3 is not divisible by 32, thus implying that plus 3 is our remainder.
Okay. Yeah, good. Okay, so just to repeat what he did. Okay, in this case, because the digits were 2 and 3, he could leverage it. So what he is doing, just to repeat, what he did is, so 2, 3, 2, 3, 2, 3, and so on. And then I'll write it till the very end. So 2, 3, 2, 3, 2, 3. This is the far end of it. Now, he's just ditching this 2 because this is 2 into 10 power 45. And then after that, he's clubbing them in pairs, 32, 32, 32, 32, and so on till this 32. So he's saying this 32 is 32 into 10 power 43, right? And then this is 32 into 10 power 41. And this is 32 into 10 power 39, and so on. And this is 32 into 10 power 1. So till here, all of these numbers have 32 in them. They're all perfectly divisible. 10 power 45 has ample number of 2s, right? We only need 5 2s to generate a 32. And therefore, this is also divisible. The only remaining number is 3. That's what he did. Arnav, did I repeat what you said? Okay. But the only problem is, instead of 2 3 2 3 2 3, had the problem been 6 7 6 7 6 7, then his process would not have worked. Because 76 is not divisible, 67 is also not divisible by 32, right? Then he has to resort to what I did, right? He has to look at the last 5, and then just you divide this alone by 32 and see what the remainder is. Does this make sense to you, everyone? Sringa, does it make sense to you completely? You're on mute, Snigdha. If you're saying something, I cannot hear you.
Yes, sir, I understood.
Understood, right? What did you do, Snigdha, to solve this problem?
Sir, I looked at the last 5 digits.
Last 5 digits, no? Okay. How about others? Sana, what did you do?
I did a similar strategy.
As me or Arnav?
As you.
Okay, last 5 digits. Okay. So yeah, if it's a power of 2, it's very easy. Last n number of digits. For example, Saurabh, to test if a number is divisible by 128, last how many digits should I look?
So 128.
Yeah, if I have a billion digit number, a large number, if I ask the question, if I divide this number by 128, what is the remainder? Then you need to focus only on the last dash number of digits. What is dash?
So 9.
Why 9?
So 120.
Yeah, 128 is 2 power what?
So 2 power 9, right?
2 power 9 is 128. What is 2 power 10?
No.
Okay, guys, powers of 2, you cannot compromise on powers of 2. You should know powers of 2 like You're left. 1024 is 2 power 10. 128 is 2 power what, Ashi?
So 7.
7. Yeah, can just literally hand count, right? But anyway, milestones you should know. 2 power 5 is 32. Okay. And then 2 power 10, like I said, is 1024. Even if you didn't know 128, that's fine. You can start counting from 32 onwards. So 5, 6, 7, right? So I have to look only at the last 7 digits. Okay, guys, it's very important to know powers of 2, powers of 3, perfect squares, perfect cubes. That's something I harped on in the first class itself, right? Because one, it will save you ample amount of time, right? And reverse, suppose someone asks you what 2 power 7 is, you guys can figure out. But suppose you see a number 128, you should realize it's 2 power 7. That connection is important, going back and forth. Okay. In fact, let's test how well you guys are prepared with this mental sort of thing, right? So I'm going to call out some numbers. You guys should tell me what you think is, what does 529 mean to you, Rachit?
20.
Are you Rachit?
Yeah,
Rachit, go
I
ahead.
don't know.
Okay, go ahead, Ashi.
23 square.
20 square. Well done. Yeah. Okay. So this is how I'm going to give you a few patterns. Okay. Sana, 343 means what?
Can it also be cubes or just
Yeah, it can be anything. Powers of 2, squares, cubes, powers, anything.
Oh, if it can also be cubes, then I'll get confused.
So can I answer?
Yeah, go ahead, Snigdha.
7 cube.
7 cube. Yes. Akshaj, what is 243?
3 raised to power 5.
Excellent. Neve, what is 729? Okay, Saurabh, what is 729?
So 729, 27 square.
27 square. Okay. Snigdha, anything else? 729?
So it's 9 cube.
9 cube, yeah.
Okay.
Which
Anything
is,
else?
3 to the power 6.
Yeah, it's 3 power 6 as well. Okay. Gyan, let's see. 961.
31 square.
31 square. Okay. Arnav, what is 8 cubed?
So
8 cubed is what?
64 times 8.
Again, powers of 2. You should know.
8 cube is 512.
5 and 2, correct, but slow. Okay. All right. Next, let's check. Is 899 prime or not? Gyan, is it prime or not prime? How do you check quickly? Actually, in fact, I'll open it for anyone. Okay. Since a different type of question. Ashi, Sana, Snigdha, anyone? Okay, I'll give a hint. What is the perfect square after 899, Ashi? What's the perfect square after 899?
After 899, 900.
900. 899 is 900 minus 1. Does that help?
So what then?
Yeah, Akshaj, go ahead.
29.
Exactly. And why 29? Because it's 30 square minus 1 square, which is 30 plus 1 into 30 minus 1. Okay. So always when asked whether something is a perfect square, so something is a prime, look for a perfect square right after that, so that you can see whether it's a square minus b square is applicable. Okay. Rachit, does this make sense to you? Okay. So can you answer if 2021 is prime, Rachit?
2021. The nearest square is what's the nearest square?
You tell me. Jan, what is the nearest square after 2021? Yeah, Snigdha, go ahead.
I'm not sure. I think it's 2025.
2025. And 2025 is what number square, Snigdha?
45 square.
45 square, yes. And therefore, can you complete it, Snigdha?
Yes, sir. So 20. So then it's 45 square minus 2 square, which is 47 into 43.
Correct, right? Which is why it's not prime. But suppose you have to manually check. We'll check prime numbers from 2, 3, 5, 7. We'll keep getting no. At some point, let's say we check till 23. We'll get, okay, ab tak nahi hua, surely it must be prime. All right, or some people might go a little ahead, 29 tak jayenge, 31 tak jayenge. Maybe they'll go till 37. They'll get, or maybe till 41 and then say, okay, up to I have to stop. Definitely prime. You have to go till the very end because it's the product of 43 times 47. So I can always make a number which is product of two successive primes, big numbers, and then it can frustrate you till the end, but you have to cross the square root. Only then it can be assured. Does it make sense, Ashi? Yeah, to check if something is prime or not. Okay, all right, one other question. Tell me a 3-digit number. This question is for, let's see, Jan. Okay, tell me a 3-digit number ABC. If I put ABC
Wait,
like,
so 1 second. So if the nearest square, like basically, if the nearest square, when we apply this principle, it does not work. As
then
in,
you have to manually do it. For example, had it been 2023, okay, so that does not work, right? 2025 minus, okay, by the way, 2023 you should know, because since the year is 2023, you should know the prime factorization of this. I'll tell you right now, it's 7 into 17 into 17. If you check immediately, you'll see it's divisible by 7, and then you will see it's 7 into 289, and then you guys are good enough to know that 289 is 17 square. So 7 into 17 into 17. Okay, Rachit, how many factors does 2023 have?
So it's 2 times 3, 6.
6 factors, correct. Okay. All right. Let's see, Arnav, how many perfect squares are factors of 2023?
How many?
Perfect squares are factors of 2023.
1.
Which is that number?
289.
Agree or disagree, Rachit?
Yes, I agree.
disagree.
Sorry, Snigdha, go ahead.
Disagree. There's also 1.
Exactly. 1 is also a perfect square, right? Yeah, very good. Yeah, so it's 7 power 0 into 17 power 2. We can use the same basket wala trick, right? I have a 7 wala basket, which has, sorry, 7 power 1. Okay, I have a 7 wala basket. I have a 17 wala basket. Okay, now to generate a perfect square, I need to pick even number of entries from each basket. From 7 wala basket, I have only one option, namely I have to pick only 0 7s. Whereas 17 wala basket, say I can pick either 0 17s or 2 17s. Therefore, there are two options, and namely the numbers 1 and 789 and 289. Make sense, everyone? Neve, are you with me completely? Pakara, Neve?
Yes.
Okay.
Yeah.
Okay. I was going to give this to Arnav, but Neve, tell me a 3-digit number ABC. If I put a bar on ABC, it means it's a 3-digit number. Okay. Tell me a 3-digit number ABC, which is a perfect square, and CBA, the reverse, is also a perfect square.
So 121.
Oh, good. 121. Okay. Now, yeah. First of all, can we exhaust thing where A and C are same? In which case, it'll be same. 121. Anything else where A and C will match? Akshaj?
169.
Correct. 169 where they don't match. 169 and 961. Yes. But like 121, anything else, Akshaj, where the first and last digit are same?
No, sir.
There is.
What did I know of?
Definitely there is. Can you think? Yaniv, you have something? What is 22 square? Yaniv?
1, so I have 1.
Go ahead.
So 676.
676 is 26 square, correct? And also 484. Yeah, thanks for spotting 676. I was not thinking of that. Okay, yes. 676 and 484, which is 22 square. Okay, but 169 is interesting because 169 and 961, the reverse, as well as you get 196 also, which is not reverse, but jumbling it in another way, you get 196. All three are perfect squares. And further, one more interesting thing, 169 is 13 square and 961 is 31 square, and 13 and 31 are also reverse of each other.
So also there's 12 square, 144.
12 and 21.
Exactly, 144 and 441. Yes. Okay. Yeah, there are a few of them. So yeah. Okay, cool. So bottom line, perfect squares, perfect cubes, you guys should be on top of it. Okay. Maybe one last question. Okay, all right. Let's do one more on factors. Okay. How many just one second. Okay, yeah. Okay. How many numbers less than 1,000, less than or equal to 1,000, let's say. Okay, I'll write out. So 1 less than or equal to n, less than or equal to 1,000. N is an integer. How many such n's will have exactly 5 factors? Okay, can you guys think about this? How many numbers from 1 to 1,000, both inclusive, will have exactly 5 factors? Snigdha, your camera is again off.
So can you repeat the question once again?
1 second.
How many numbers from 1 to 1,000 inclusive will have exactly 5 factors? Sorry, Snigdha, I'm just seeing your message now. Could you explain question 4 again? Was that after that? I did explain after that, or I don't know. I'm just seeing the chat. Snigdha.
No, sir. It was the last term explained last class.
Last class. Oh, okay. All right, we'll come back to it. Oh, the Nonagan one. Okay, I see. Yeah, we can do that. No problem. Okay, Jan, you don't have to tell the answer, but what is your initial observation? Typically, what sort of a number will have 5 factors? Anything that you know?
The squares of perfect squares.
Squares of perfect squares.
Prime
Excellent.
number.
So like,
So squares of no. Almost right. Yeah, go ahead, Snigdha. What did you say? Snigdha, you said something.
No, so I was just asking how are squares of perfect squares.
Squares of perfect squares मतलब fourth power. वही बोलने चाह रहे हो ना ज्ञान?
yes,
Power.
sir.
Almost right. One small detail you're missing. An important detail you're missing. Fourth, he's saying fourth power because when you have fourth power, you'll have 4 plus 1. Fourth power of Gyan?
Of prime numbers.
वो बोलना चाहिए ना. So it must be a fourth power of a prime number. Only then such a number will have 5 factors. Why so? For example, had it been 2 power a into 3 power b times 5 power c and so on, the number of factors will be how much? A plus 1 into b plus 1 into c plus 1 and so on. Right? Now I want this product to be 5. Correct? I want this product of all of these a plus 1, b plus 1, c plus 1 to be 5. But 5 itself is a prime number. How can I get a product of several numbers being 5 unless one of them is 5 and everything else is 1? This is 5 and everything else is 1. So, which means in this example, it's 2 power 0 into 3 power 4 into 5 power 0 into 7 power 0. All the other primes do not count as in power 0. There's only one prime number to the 4th power. Therefore, it has 5 factors. So a 4th power of a prime number will have 5 factors. Does this make sense to everyone? Neve, are you with me?
So it'll be 16, 81.
16. Okay. 16. Okay. All right. Do you guys, now that you know this, 16 is Sana's answer. Let's wait
No,
here. Some other.
there'll be more than 16.
More than 16. Okay. Then
No,
what is?
as in, like there'll be a total of like maybe 3 to 4.
Okay. Okay. Oh, you're saying the number 16. Yes.
Yeah.
The yeah. 2 power 4 will have 5 factors. Let's check. 1 into 16, 2 into 8, and 4, of course, is just 4. So we count only once. It has only 5 factors. The number 3 power 4. Yes.
81.
So 81.
Yeah. How many? How many? Just answer my question. How many?
Sure, I got 3.
Only 3.
So
Okay.
I got 4.
4.
For 3.
3. Okay. So 2 power 4, 3 power 4, 5 power 4 is 625. 7 power 4 will exceed 1000. No. So only 3. Only 3.
What
Yes.
about 1?
1 will get, sorry, 1 will have only one factor, no? We want numbers which have 5 factors. So it must be a prime number power 4. 1 is not prime. So 1 power 4 will not count. 1 is not prime. The prime factorization will not have 1 in it. 1 is neither prime nor composite. It's unique. So, yeah, but good question, right? 1 is not prime. Therefore, it does not figure. Yeah, 1 is the only number which has exactly 1 factor. Every prime number has 2 factors. Okay. Ashi, which are the numbers which will have exactly 3 factors?
So from 1 to 1,000.
No. You just tell me the quality of a number which has exactly 3 factors.
Give me 1 second. So if it has 3 factors, it'll have to be before
Your voice is breaking up quite a bit. No, not Jan. I want Akshaj.
Yes.
Akshaj. What is the property of a number which has exactly 3 factors?
Would it be a prime square?
Prime square. Correct. Understood. So first of all, it's a perfect square. It has odd number of factors. That we all agree. Okay. Arnav, can you explain why a perfect square has odd number of factors?
Explain.
Yeah, any perfect square, it will have odd number of factors. A couple of ways in which you can explain.
So they have odd number of factors. So if they're prime numbers, they only have their only factors are 1 and itself. And if you are squaring them, then you will have that prime number twice and 1.
Yeah. So if it's a proper prime square, then the 3 factors are 1, p, and p square. It has 3 factors. That we agree. Which is what someone answered just before this, right? I forget who that was. If a number has 3 factors, it is a prime cos square, right? But I'm asking if a number has an odd number of factors. What was I saying? Or rather, I was asking, why does any perfect square have an odd number of factors? It need not be a prime square. For example, number 36 is not prime cos square. It's 6 cos square, and 6 is not prime. Or number 100. 100 is 10 square. 10 is not prime. But these numbers also have odd number of factors. Why is that, Arnav?
Sorry, sir?
Yeah. So 36 is perfect square, but not a prime wala square.
Yeah.
100 is a perfect square, but not a prime wala square.
Yeah.
But still, these numbers will also have an odd number of factors.
Yes. Sir.
Why? My question is, why is it that perfect squares have odd number of factors? Yeah, Snigdha, go ahead.
So because with every factor, like they multiply in pairs to form the number.
Exactly.
Whereas when there is a perfect square, then one number will have to multiply with itself. Then there's no pair, which ends up being
Exactly.
odd number.
Exactly. When I do Jodis and write it out like this, 2 into 50, 4 into 25 like this, at some point I'll get 2 numbers which are same. So you're counting everything 2, 2, 2, 2. The last line alone gets counted only once. And therefore it has odd number of factors. That's one way of looking at it. Arnav, is this clear? Can you describe another way, guys? Anyone else? By which you can say that perfect squares will have odd number of factors. Using the prime factorization method. Okay, I'll prompt you a little bit more. Yeah, go ahead, Rachit.
So can I
Rachit.
So because it will be the number to the power of 2, therefore you'll add 1 to it, which will make 3 factors.
But you're not adding. So for example, 100 is 10 power 2, but you're not adding 2 plus 1 and saying 3 factors for 100. 100 has a lot more than 3 factors. Right? But you're close. Gyan, go ahead, please.
So a square is basically a number raised to the power of 2. So when it is when it is raised to the power of 2, it has odd number of okay. So can I just have 2 seconds to recall again? That's
Okay, sure. But meanwhile, someone is ready, you can go ahead. 2 hours, you said, Gyan? 2 days.
Sir, I said 1 minute.
You said 2 something. You didn't say 1. Okay, bolo. Chalo, it's fine. I'll help you. Go ahead.
Okay, so when a number is squared, when a prime number is squared,
Yeah.
it will have three factors.
That we agree. Yeah.
One, then the square and the number itself.
Yeah.
So the three is a prime number. So according to the prime factorization method, with you can't multiply. There aren't any factors of three except for 3 and 1. So you can't get multiply and get 3. So in that way, the powers of 2 have not the power of 2. Powers raised to 2 have odd number of factors.
Not very clear, Nyan. I have a vague idea that you are on the right track, but it's not coming out well. Anyone else? Sana, you want to try? My question is simple. Any perfect square has an odd number of factors. Why? Snigdha gave one answer, which is perfect, which I agree. You put jodis, the last line will be not a jodi because it will be the same number, therefore odd number of factors.
Yeah.
Some other way, using prime factorization, can you tell me why a perfect square has odd number of factors?
Okay, so when you're, can I give an example?
Yeah, you can give an example to illustrate.
Yeah.
Fine, let's see. Okay.
I guess using 36 only.
Okay, 36. Okay.
Then you can branch it out into 3 and 12.
Okay.
12 will go into 3 and 4.
In general, one advice, whenever you're dividing up a big number, go in big chunks rather than one small number or one big number. Go as 6 and 6 rather than, right? For example, if I have...
go from smallest to...
No. When you're writing them as jodi, you will start with the smallest. When you're doing a, for example, 600, suppose someone asks me, I'll go big chunks, 24 and 25.
600.
Right? Not 6 and 100. Go even bigger, 24 and 25, for example. You should know it's divisible by 25 by now, right? And then this is 4 and 6. You can quickly reach the end if you do this. So this is 2, 2, this is 2, 3. On the other hand, if you start with 6 and 100, you'll be there forever. You'll be like our Gyan's 2 minutes, 2 seconds. Wala. Yeah, okay, all right.
Okay, so 6 and 6 goes in 2 and 3, 2 and 3.
Yeah, correct.
So that's 2 square and 3 square.
Yeah.
So 2 square added 1 becomes 3, and for 3 square, if you add 1, it'll be 3. So wait, what?
Yeah, it has 3 into 3, 9 factors. Correct. Which is odd number of factors. Yeah. You have given an example. 36 has an odd number of factors. But what are you trying? How are you trying to establish this?
So basically,
yeah, no, you are right. It has odd number of factors, namely 9 factors in this case. Okay, Gyan, are you able to develop further? Are you very collected your thoughts?
Okay, so essentially,
no, sir, I'm actually still gathering my thoughts.
Okay.
Like, I have the basic idea of how to actually, but I'm not able to like get it out.
That's fine, no problem. Sana, you were saying? Yeah.
So basically, for any number, I guess it would be a number squared. Or 2 numbers which multiplied squared would make the square number. So it'd be AB okay.
You're almost right.
But yeah, so if it's A times B whole square, it would be as prime factor.
But let's take number 81. 81 is not a square, right? It's 3 power 4.
Yeah.
It has an odd number of factors, namely 5 factors.
Oh.
Right? But you're almost close. Anyone? Okay, guys. Any perfect square will have 2 power some even number, 3 power some even number, 5 power some even number. Every prime number will appear for an even number of powers. And therefore, that even number does not have to be 2. That's what I was saying, Sana. It could be 0, it could be 4, it could be 6, whatever. But it's an even power, right? For example, the number 2 power 6 into 5 power 14 is also a perfect square. It's the square of 2 cubed into 5 power 7 ka square. right? So, and because all of these powers are even, when I add 1, 1, 1, 1 to them, they'll become odd, 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 odd. When I multiply the odd, 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 I get an odd. The only way to generate an odd number is product of several odds. And when you get product of several odds, when the predecessors of all of those numbers are evens, which means a number whose prime factorization is such that the powers of each of those primes are evens, such a number will have odd number factors. And what is such a number? A perfect square. Saurabh, does this make sense to you? Neeb, are you with me as well? Everyone with me? Okay. Everyone, right? Okay, cool. Okay, maybe one last question on the same thing. Okay, now 5 factors ke liye we answered. How many numbers less than 1,000? How many numbers less than 1,000 will have exactly, forget less than 1,000, let's do smaller. 1 to 100 will have exactly 6 factors. 1 to 100. How many numbers have exactly 6 factors? Okay, think about it, guys.
Prime numbers to the power 5.
Good. Okay, that's not complete, but yes. So if I have a prime number power 5, if P is a prime number, that will have 6 factors. How many such numbers do we have, Saurabh? Not Snigdha, Saurabh. How many such numbers do we have from 1 to 100, which are a prime number power 5? From 1 to 100. Saurabh. Saurabh is frozen. Saurabh, is your camera working? Is this thing working? Okay.
Sir, is it 3? No, sorry. 1 second.
No, I'm giving it to Saurabh.
It's
Arnav.
2.
Arnav, please.
No.
Saurabh, how many prime power 5 are there between 1 to 100?
So prime numbers raised to 5.
Should be, you understand why prime number power 5 has 6 factors, correct? By the logic.
Can you repeat?
Okay. No, my question was, initial question was, how many numbers from 1 to 100 have exactly 6 factors? Now, Snigdha said, such a number, which will be P power 5, will have 6 factors, where P is a prime number. That makes sense, right? Because when I add 5 plus 1, so for example, let's P, Q, and R are all prime numbers. There's no other prime number, right? Q power 0, R power 0. There's only one prime number P, uska 5th power. How many such 5th power of prime numbers exist from 1 to 100? Saurabh.
So you first take the largest 5th power before 100.
Which is the largest 5th power before 100?
So I think 2 raised to 5.
Yeah, 2 raised to 5 is how much, Saurabh?
64, right?
32. Milestones,
32. Yeah,
32. On model 3, what is 3 raised to 5, by the way, Saurabh?
3 raised to 5. 3 raised to 5.
Okay, go ahead and please revise all the perfect squares, perfect cubes, powers of 3, guys. Okay,
Is it
so
243?
243, yes. So bottom line,
Yeah.
there's only 1/5 power of a prime number from 1 to 100. Same, namely 2 power 5. Okay, but Snigdha's answer is not complete, right? It's not just 5th powers of prime numbers. Yeah, Arnav. Not just 5th powers of prime numbers, but also what other
Powers
numbers?
of all numbers below 100. So it's even 1. It's basic. There's basically 2 numbers. It's 1 and 2, because 1 raised to power 5 is 1 and 2 raised to power 5 is 32.
1 raised to power 5 is the number 1. How many factors does the number 1 have? Only 1. I told you just a few minutes ago, 1 does not figure out in the prime factorization business at all. So don't count 1 that way.
So I just forgot about the question altogether. I was just thinking about that way.
Okay, all right. So, okay, so just to extend on what Snigdha said, so 5th power of prime numbers, we all agree have 6 factors. And there's only one number, which is 2 power 5. But there are more numbers which have 6 factors.
So there's also 12, which has 6 factors.
Yeah, and so what is the nature of that such number? Like in terms of prime factorization, how will they look like? So for it to have 6 factors, how will the prime factorization look like?
So is it a square into an odd number as well?
Square into
Odd
prime-
number or prime number? Prime number.
Exactly. So it's P square into Q power 1, where P and Q are prime numbers. Whatever I'm talking, they're all prime numbers, right? So P and Q are prime. So if it's this, then it'll have 2 plus 1, which is 3, times 1 plus 1, which is 2, will have 6 factors. So any number of the form P square into Q, where P and Q are prime, will have odd number of factors, or will have 6 factors, I'm sorry. Okay, so now that you know, can you count and tell me how many?
So under 100, right? Or 1000?
1 to 100, both included here. Neve, you're following along, right? All good so far?
Yeah.
Okay, cool. Okay. Jan, how long more?
So
2
I'm
seconds?
calculating. Yeah. So like 30 seconds.
30 seconds. All right. Okay, ho gaya 30 seconds, Jan.
Still calculating. So
Okay, anyone has an answer? Akshaj, what's happening?
So I'm still solving it. So
I'm not sure, but I think it's 44.
44.
So
Okay.
I think I got 7.
7. Okay. Okay, 2 wide answers.
Oh wait,
44.
sir, I'll let you change my answer actually.
2.
1 second.
Any other answers, guys, other than 7? Okay, let's start to discuss, guys. We have been on it for some time. All right. Yeah, unless someone stops me in the next 10 seconds.
I got 16.
16. Okay, all right, let's discuss. So P square into Q. So it's 2 square into 3, 2 square into 5. So let's see how many in the 2 square wala series. Okay, so I'll just write this as 2 square into something, right? So it can be 2 square into 3, 2 square into 5. So 2 square is how much? 4. We can go all the way till 25. List out all the prime numbers: 5, 3, 5, 7, 11, 13, 17, 19, 23. Okay, we finish the 2 square wala series. So it's 2 square into 13 power 1, for example. 2 square into 19 power 1, and so on. Let's go to 3 square series. 3 square is 9. 9 into 2. It cannot be 3 again, right? Because 3 is already taken. So again, all the way till how much? 100 divided by 9 is 11. I can go all the way till 11. So 2 ho gaya, 5 ho gaya, 7 ho gaya, 11 ho gaya. Next, we'll go to the 5 series. 5 square is 25. We can go all the way till 100, which means till 4. So 5 square into 2, 5 square into 3. 7 square is 49. So we can go only till 7 square into 2. 11 square is already 121. So there's no scope. So all of these numbers, plus that one number that we saw earlier, which is 2 power 5, We'll all count. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Very well done, Akshaj. 16 indeed. Okay. What is the mistake? Whoever said 7, were you able to find your mistake?
Sir, a very big mistake, sir.
Sorry?
It was a silly mistake, sir. I did not count some numbers. I missed some of the numbers.
Fine. Okay, no problem. But did you guys all understand this very well, guys? This prime factorization is
Yes.
extremely important, right? Going forward, not just for AMC8, like a lot of the questions in AMC10, AMC12, all of them will be, if you have to have a good grasp on prime factorization, right? It's extremely important. I cannot emphasize enough. Okay, let's move on
Can
with
you
the
explain how you did this one again?
Akshaj, you explain, please.
Okay, so basically, since we already had the 2 raised to 5 is 32, so that's 1 and we can leave that. The second type is p square into q raised to 1, where both p and q are prime numbers. So we can take 2 as the smallest prime number. So 2 square is 4. So 4 into 25 is 100. So we can take all prime numbers below 25. Since 25 itself is not a prime number. So we cannot take 2 again because it's already been used as p. So we get 8 possible q's if we take p as 2. If we take p as 3, again we can multiply it by all factors below. So p square will be 9 in this case, because if p is 3, 3 square is 9. So we can take it till 11, because 9 11s are 99, which is the closest to 100.
Yeah. Very good. Very well explained so far. And then from there on, it should be clear, right, Arnav? Is this clear? Yeah, same pattern. Yeah, very well explained. Yes. And then 5 square, 7 square, and then the moment you cross 11, it's already more than 1,000, already more than 100, right? So there's no scope. So the last number would be 7 square into 2, which is 98. Or in fact, the last number would be 99, because 3 square into 11, that's 99. So we have extracted the maximum juice from this, right? 99 tak pahunche hum log. Okay. Okay. That was question 7. Okay. Yeah. Snikta, you wanted to discuss question 4, right? We'll come to that. One sec. I just want to get a little bit ahead and then we'll come back. Question 8, rhombus square. Saurabh, we're able to do this question 8, rhombus and square wala question.
The question 8. The rhombus, no, sir. That was the only one I got stuck in.
Okay. All right. Neve, what about you? Did you do this one?
Well, I tried, but no, sir.
Okay. All right. Ashi?
So somewhat. Yeah, I think I've gotten an answer.
Okay. What is your answer? Please call out.
11.
11. Snigdha, did you get the same answer as her? 11?
Yes, sir.
Okay. Ashi, can you explain what you did to get 11?
So we know the height will be 20 by 5 because the area is 20. And so then you get 4 centimeters. So QU square is equal to QV square plus VU square. That is the, yeah.
Okay. So 5 is the side of the square and 5 is the side of the rhombus as well. Okay. And then after that, the height of the rhombus you said was 4. Is that what you said?
Yeah, I said the height will become 4 centimeters. Yes.
Okay, because the area is base into height for a rhombus. Therefore, the height of the rhombus is 4. Yes.
Yes.
Okay.
So after that, you do the root of 5 square minus 4 square minus 3 out of the. So you take the line. X will be this part. Is it all
okay.
right?
Yeah, please, Anand. Or you tell me what I should do, and then I'll draw that. From you wanted me to draw perpendicular, is it?
Yes, sir. So you can. I've drawn a line between U and V, and I've drawn a.
Well, what is V? What is V? This point below, is it?
Yes, so you know the point where the line is ending, like between Q and R.
Okay, I'm calling this V, and I'll call this W. Okay, now dictate What
So,
else?
so now between Q and V, I've taken that to be X.
Okay, this is X. Okay.
Then the point, like, the line R, yes, that's W. Yeah, okay. So now after that, I've taken that UW is equal to VR is equal to 5 minus 3 centimeter, which is 2 centimeters.
Okay, so X you arrived at was 3 because of the Pythagorean
X I
triplets,
arrived
right?
was 3 because
Yeah. Yeah. So
minus-
this, yeah, so this is 5, and therefore the 5, 4, 5, 3, 4, 5 triangle. This is 3, and this is 2. Okay, go ahead, please.
So area of the trapezium UQRW is half into 2 plus 5 into 4 centimeters square.
Okay, so this is 2, and then average of the two bases, which is 2 plus 5 by 2 times the height, which is 4. So how much does this work out to be?
14.
14. And therefore you're subtracting 14 from
25 minus 14, yeah.
Yeah, very well done. Yeah, I hope others also did something very similar, right? We'll start off with the rhombus wala height.
So I did something
I
similar
did it
and I got
slightly
14
differently.
as
Okay.
So I
Snigdha,
got 14 as well.
you got 14 as well, but Snigdha, you said you
It's
did something
11,
different.
not 14.
Sorry, 11. 25 minus 14, which is 11. What happened to my Zoom? Just 1 second, guys. I'm losing track of something. 1 sec. Let me just reshare. Yeah. Sorry, Snigdha, you said another way, right? What was the way?
Wait. So what I did was, again, I got the height to be 4.
Yeah.
So then I extended the line UT to, wait, can you just...
Okay, yeah, I'll erase all of this and then, okay, and then you can dictate what I need to do. So I'll extend the line UT till it intersects P, is it?
Yeah.
Till it intersects, okay.
Yeah, so then we extend it as a straight line, and it
Okay.
forms a to some like X point.
Okay, so I'll call this point X, okay.
And that forms a right angled triangle.
Yeah.
And since we know that this is since we know that XQ is 4 and that is 5, then yeah, that so then XU is 3.
Mhm.
And that means that
you're adding the rectangle and the triangle. So half into 3 into 4 is the triangle XUQ, and then the upperwala is 5 into 1, I guess.
Yeah.
Right? So you get the same answer, 5 plus 6, which is 11. Okay. All right. Same thing, right? Very similar. I can do some other ways also. All of them are very more or less same thing. Okay, let's move on. Let's do the next one. The two 3D objects.
So,
yes.
so
yes.
Since how did you get XQ is equals to 4?
Oh, that's because the XQ is the height of the rhombus, right? We agree the height of the rhombus is 4 because the area of the rhombus is basically.
Oh, yes, yes.
Right, this is 4.
Sorry.
Okay. The 3D wala question. Let's see who did this one. Jan, were you able to do this one? The 3D question.
Which one, sir? The ninth one.
Question 9. So let me just create more space here. Okay, question 9. Yeah, this one.
So I got 42.
42. Okay. Others, Rachit, what did you get?
What?
So I also got 42.
So I got 38.
Okay.
So even I got 38.
Okay. 32 and 38 and 42. Any other answers?
I got 45.
38, 42, 45, 40. Okay. All right. So let's discuss.
So
okay.
I got 30.
30. Oh, wow. 5 answers. 30, 38, 42, 45, 40. Okay. All right. So you guys are able to visualize this, right? So you have another picture. In fact, I'll take another one of this, right? So for people who are not able to visualize this, you bring this guy and this guy together, and you make this ulta, right? You reverse this, right? And then you plug it in here, and then you make this object, right? Are you guys able to visualize this? I mean, I cannot visualize it for you, but you'll have to visualize it yourself. Yeah. So essentially, when you reverse this, Okay. And then, how shall I say this? Yeah, I mean, you have to visualize this, guys. I don't know. Is anyone not able to visualize this diagram, the 3D diagram? I'll help if in describing. But otherwise, you're all able to visualize this. All okay, Neve, able to visualize? Ashi, you're good? Okay. Now, if I look at it from the front, here, from this angle, okay, how will this object look like? It'll look like this. It'll look like this. Okay, and it'll be like this. Okay, so or maybe slightly more like this. Okay, in other words, this, oops. Okay, in other words, this square portion will be visible here. This half square will be visible here. So if you look at it from a distance, you won't see the depth. It's called the front view. You will see all these building diagrams, they'll all be like this. There'll be something called a front view, also known as elevation. There'll be a top view, also known as a plan. Okay, but there's this terminology. But when you draw a building, you'll see the plan. From the top, how does it look like? You have this play area, you have all this building, tower A, tower B, there's a swimming pool, all of this, right? Those are all plans from the top, helicopter view. There's also front view, which is elevation. So standing on the street, how does the building look like? Second floor, third floor, all that, right? So if I'm looking at it from here, it looks like this. If I'm looking at from all the sides, it's going to look very similar, right? It's going to be one square followed by a half of the square. So all of these 4 sides are all identical, and they're all going to be what? 2 by 3, because a 2 by 2 square and a half of that square. So you have 6 square centimeters, and there are 4 such side faces: left, right, front, and center. Left, right, front, and back. Now comes the top view. So top view is, if you're looking at it from the helicopter, also known as the plan. So if you're looking at it from the top, how does it look like? It looks like 2 overlapping squares. It's a square and then another square like this, right? So the overlap portion is repeating like this, right? So what is the area of this one? So this is 4 individually. This is 4, 2 square plus 2 square. But then this overlap area is getting double counted. So I have to subtract that. So it's 7 square centimeters at the top and 7 square centimeters at the bottom as well. So 7 into 2. So 24 plus 14, which is 38 indeed. Thankfully, that's one of the 5 answers. Okay, does this make sense to everyone who got an answer other than 38? I've lost track of who got what, but you guys agree on this one now?
So can you
7. So can you explain the 7 into 2 again?
7. Okay, from the top, this is the top view. From the top, if you see from here, there are 2 squares, right? They're overlapping like this square and this square. And then this small portion is the overlap area, which is getting double counted, which I have to subtract. So the total area is at the top is only 7, not 8. Right, and exactly same at the bottom as well. Make sense?
Oh.
Yeah. All of you good on this one, right? Yeah. Yes.
I did a calculation error.
area 7.
I did a calculation error.
Okay. Okay. Fine, Jan. Sorry. Heard some girls' voice. Snigdha, was that you or Rashi? What is the doubt?
Sir, I didn't understand why how was 7 unmute.
You understood the 6 into 4?
Yes.
Okay. The 7 into 2 is what you didn't understand. From the top, you agree that the shape is this. This is the shape from the top, right? Which is 2 overlapping squares, right? And that's the exact shape I've drawn here.
Oh, okay. So then it's 2 squares of 2 squares of
4 each.
4 each, and there's 1 centimeter square overlapping, which makes it 14.
Yeah, which makes it 7 rather, and then you
Yeah.
apply the same thing at the bottom as well. So 8 minus 1, which is 7, and then exact same thing at the bottom as well. Okay. All right. So Jan said he found his mistake. Others also were able to find your respective mistakes. Or everyone is clear with this one? Okay. All right. Let me ask one extension question on this one. Okay, I'll erase all of this. If I label this point as okay, I'll label this point as A here. this point is A. The bottom may this corner is A, and top may this corner is B. Can you find the length of AB as you pierce through the object and go inside that solid? What is the distance AB be? Find the length of AB.
So I couldn't hear you properly. Can you
Find the length
repeat the question?
Find the length of AB, where A is this bottom corner, B is this top corner. The straight distance AB as you pierce through the solid object, what is the length of ABB?
So the distance between slanting or
The slant, the diagonal, the sort of the 3D diagonal that goes inside the object. It's called length.
So basically, you want us to find the length of that slanting line, right?
Correct. The 3D diagonal, the slanting 3D diagonal.
Sure.
Okay. Yes.
Sir, around 6, I
No,
got it around.
You can tell me, even if it's an irrational number, you can, for example, if it's square root of 31, you can just say square root of 31. I'm just saying some random number.
Okay, sir.
Obviously, that's not the answer. You can just tell me in terms of fractions or irrational numbers. You don't have to give me decimals. So you're saying it's 6 point something, is it?
Sir, around 6. I got 5 point something, around 6.
Okay. When you say around something, that means you must have gotten some number, right? Some fraction or
Yes,
some
sir.
root. What is that? Tell me that exact one.
So 5.656.
Are you calculator use kar rahe ho kya? No, without calculator, you have done some expression, right? Tell me that expression
Yes,
as
sir.
it is. What is that expression?
Okay. So, sir, root 2 plus root 2 plus root 2 plus root 2. That's 4 times root 2. So root 2 is 1.414, so I multiply.
Okay, so 4 root 2 is what I expected. But yes, 4 root 2 will be 4 into 1.4, which is 5.6. Okay, that is his answer. I'm not saying it's right or wrong. Okay, any other answers? Sana, how's it going? Should we discuss, guys? Or anyone is close to having an answer? Arnav?
Sir, I'm still figuring out how to approach this. I'm trying different methods and all of them are failing.
Okay, all right, I'll help you guys. Okay, so let's look at this corner also. Let's look at the number AC and then B. Okay, so now in 3D, you have to visualize. So let's visualize the triangle BCA or ABC, whatever, right? This is a right angle triangle in 3D. Are you guys able to visualize this? That this is a right angle triangle. The right angle is at C. You're able to visualize. So essentially BC ka square plus CA ka square will be AB ka square. Do all of you agree with this so far? Right? Okay. Now CA to pata hi hai. We all know CA is 2 because the side of the cube is 2. Now BC is also easy. BC is what we have upar se dekhoge, so this is, we have, this is B and this is C, right? That's two extremes on the square, right? So B is sitting somewhere here and C is at this corner.
Wait, I'm not sure if it's right, but I think I got 2√6.
2√6. Okay, all right. We'll discuss 2√6. Okay, so B is here at the top. So B is here and C is here. Now this is a length of 2, this is length of 1, this is length of 2, this is length of 1, which means if you travel from B to C, you're traveling 3 square plus 3 square ka root. So this is 3 and this is 3. This is 3√2. So BC is 3√2. So this is 3√2. So now we can just substitute that here. So 3√2 ka square plus 2 square equal to AB square. How much is this? This is 9 times 2, which is 18, plus 4, which is 22. So AB is square root of 22, which is not 2√6. 2√6 is approximately, not approximately, square root of 24, but the answer is square root of 22. Right? Okay, let's hear from Snigdha and Jan what their mistakes were. Jan, what did you do to get 4√2? Jan, what did you do to get 4√2?
Sir, I calculated the top height. I should have gotten 3√2, but I got 4√2 somehow.
Okay, and then after that you didn't. So basically, you found BC wrongly.
Yeah, I found BC and I found incorrect BC instead of finding BA.
Oh, okay. Incorrect BC instead of finding the correct BA. So double mistake.
Yeah.
BC may be
Double
correct
mistake.
and then finding BA. Okay.
Yes, sir.
And Snigdha, what was your mistake?
Wait, so I have a question.
Yes.
How is CA3? Wait,
C is 2. All of these cubes are side length 2, right?
yeah. Wait, so I had a question. How did you get BC?
BC. So from the top you're looking, right? So from the top view, if you look, so BC, I'll just draw this diagram again a little bit clearer. Okay. So from the top, when I draw, how will this look like? So this looks like one square aisa, another square aisa with that overlap. So that far corner is B and this far corner is C. Do you agree with this shape from the top, Snigdha?
Yeah.
Okay.
So,
and what are the lengths?
excuse me,
This
sir.
is one. Yeah.
So
Yes.
I'm really sorry to interrupt, but my mom has sent you a message that I need to leave the meeting early for some reason.
Oh, okay, fine. In fact, we are just leave, please. I'm also wrapping up in a minute. Okay, so I'm sorry.
Okay, sir. Thank you,
so 2
sir.
plus, so this is 3. This length is 3, and this length is also 3. Therefore, it's 3√2, no? By 45, 45, 90. Snigdha?
Yes.
Makes
And
sense?
it's 2 into 3√2.
3 square plus 3 square. Uska root, which is 3√2. Yeah. So if you have a 3 and a 3 and a right angle triangle, this will be A√2. So this is 3√2. All right, let's wrap here. Obviously, we didn't finish the homework, but a lot of other questions we covered. Yeah, but next class, we'll just go with the homework problems. Let's finish homework 4 properly. Okay, bye. See you.
Bye, sir.
Bye, sir. Thank you.
So I had one
Doing
question.
homework facts, right?
So for the AMC, so will it be an online exam or we have to go?
See, some schools are offering offline, and they are slowly changing with each passing session. So AMC 10 and 12, I think that more schools have opened up offline. Check the latest with G-Loops because I'm not in charge of registration. Check with G-Loops. I've passed on their numbers.
Yes, I have signed up using that.
I just asked them. Yeah.
So for question papers, so are they to go buy?
Yeah. So this Art of Problem Solving book, you don't necessarily need to buy it. There are good books to have in general, but you don't necessarily have to buy them. There's a lot of past papers already on the web for free. So use the free resources first rather than buy something and just sit idle on that. Okay.
Yes.
Okay.
Yes.
All right. See you. Bye.
Thank you, sir. Bye, sir.
Thank you, sir. Bye.